Good morning everyone, thank you for joining us for our second tutorial of the day. This, as you know, is GCSE Maths and today is a foundation session on the topic tables, charts and diagrams for data. Should be a really good session today. As usual, this session is being taught by our brilliant maths tutor Evelyn, who lots of you know already as you'll have been to her sessions before. She studies maths at University of Birmingham. So as usual, this is a 1 hour session, so we'll finish at 12. I'm Tilly, I work at my tutor. Any questions you have for either myself or Evelyn, you can just pop those in the chat or the Q&A, which you should see on your screen. We'll keep an eye on them throughout, but we will have time for a Q&A session at the very end, just to pick any of those up that we might have missed. And just a reminder, as I always say, if you want to catch up on any past sessions, either for maths or for any of our other subjects, which are biology, chemistry, physics, English and history, you can catch those on the My Tutor YouTube channel. We've got our webinars there as well as some shorter topic videos too. I'll just wait a few more moments as I know there are more people joining us today. As I mentioned at the beginning, this is GCSE Maths and the topic is tables, charts and diagrams for data. So it should be really handy. We've got another maths session this afternoon at 3:15, which is on transformation of curves part 2, if any of you joined us for part 1 yesterday. And we've got some other subjects as well later today, but I'll mention those at the end of the session. Cool, are we all ready to go?
Yes.
Brilliant, have a great session, guys.
Thank you. Right, so let's get started then. So we're going to do a quick recap on what we were doing last session. So we were doing real life graphs. So if we remember from last time, distance time graphs show distance on the vertical axis and time on the horizontal axis. The gradient of a distance time graph represents speed. So the larger the gradient, the steeper the line, which means the faster the speed of the object. And we also went through conversion graphs. So a conversion graph is used to change one unit into another. So let's say you wanted to change pounds into dollars or meters into miles or something like that. And then the final thing also is to find the equation for speed, distance and time, we should use this triangle. So remembering from last time, whichever equation we're interested in, if we're interested in speed, then we would cover speed and look at the relationship between distance and time. And we see distance over time, so it would be distance divided by time. So let's go through a quick recap question. So here we have Jamie and has travelled 20 kilometres from his home to his friend's house. Jamie then spent some time at his friend's house before returning home. And here is the travel graph for part of Jamie's journey. So the first part of this question, part A, is write down the time that Jamie left home. So what we should do is we should go to the graph and see where we started. So this should be when distance from home is 0 because it's still at home. So if we look, it looks like 10 past 10 over here. So 10 past 10 would be the time that he left home. Now always remember to read your scales properly. So when you are doing distance time graphs, sometimes it's put in a hours, or it actually gives you the time, let's say 10 o'clock, 11 o'clock, like how it's done it here. It's not always like this. So always make sure that you read the axes properly. The next part is write down Jamie's distance from home at 20 past 10. So we go to 20 past 10. If I zoom in a little bit as well, if we look at 20 past 10, then what we can do is we can draw a line that goes up to our graph and draw a line across to show where he is. So let's draw a straight line. Always remember when you're doing distance time graphs, remember to use a ruler. So at 20 past 10, we go up to, the line, which is around here. here, and then we go across. So when we go across, what we'll find is that it's around 6. Yeah, so using the scales on the graph, it looks around 6, and we already know that on our axis we have 6 kilometers. So our answer would be 6 kilometers. And then the next part of the question is saying, Jamie left his friend's house at 11:10 to return home. To work out the time in minutes Jamie spent at his friend's house. So remember, the horizontal lines on a distance time graph means that the person or the object isn't moving. They're still staying in exactly the same place. So the horizontal line shows where Jamie stayed at his friend's house. We just need to work out the length of this line. So the length goes from 10:40 all the way to 10:11. So now we just need to work out what is the time in minutes from 40 minutes past 10 to 10 past 11. What we realize is that that is 30 minutes. Then the next part of the question is telling us to complete the graph. So it says that he returned home at a steady speed, and he arrived home at 50 minutes past 11. So we know at 50 minutes past 11, he should be at home. So his distance should be 0 over here. And here is 50 minutes past 11. So all we need to do now is draw a straight line, because he's traveling at steady speed, from where he left his friend's house to home, and that will get you a mark. And the last part is now asking us to work out Jamie's average speed on his journey from his home to his friend's house. So remember last time when we were doing average speed, we used our speed equation, because that comes from our triangle that I was mentioning at the beginning. So we know that speed, try and get the pen back. Speed equals distance divided by time. So we want to find out the total distance between his home and his friend's home, and then divide it by how long it took him to get there. So if we go back, so remember he left home at 10 past 11, and he got to his friend's house at 40 minutes past 10. So we know that that's a 30-minute difference. And we also know that his friend is 20 kilometers away up here, and his home is at 0. So the distance from his home to his friend's house is 20 kilometers. Now, bear in mind, always pay attention to units. It doesn't say per minute, it says per hour. So we know it was 30 minutes to get to it took him 30 minutes to get to his friend's house. Now 30 minutes is equal to half an hour. So that would be 0.5 hours. Yeah, so we would do 20 kilometers divided by 0.5 hours. So our answer would be 40 kilometers per hour. And that is distance time graphs. So hopefully that clears everything up, and that made a lot of sense to you guys. So let's now move on to tables, charts, and diagrams for data. So I'm sure some of you have seen, if not all of them, then at least some. So we're going to be going through how to construct and interpret frequency polygons, time series graphs, bar charts, pie charts, and scatter diagrams. So let's start with frequency polygons. So a frequency polygon represents the group's data in a frequency table on a graph. So frequency polygons are also called frequency diagrams, so they're exactly the same thing. Now, an example of one is shown below. So we have our frequency table. So we have number of suites and how many suites. how many people picked those sweets, sorry. And it's represented on the graph next to it. Now, one thing we have to remember is when we are working with frequency polygons, we don't plot against the first or the last number in the interval. We plot against the midpoint. So we always have to find the middle value between each interval and plot our frequency against that. So as we can see, we've got 14 plotted against 8, and then we've got 19 plotted against 11, and so on. So frequency polygons are always used with grouped data and tables. So to draw a frequency polygon, you need to be able to draw your axes with suitable scales and make sure you label your axes as well. You need to be able to plot your frequency against the midpoint of the interval for each category. And then once you've plotted your points, you connect each of the points with a straight line. So let's go through a quick example. So here we have a table which shows some information about heights of 60 plants. So they want us to draw a frequency polygon to show this information. So the first thing I would say in any question which is on frequency polygons, if they haven't given you the midpoint, then extend your table and make a column for midpoints. So that's exactly what we're going to do here. So this one's going to be midpoints. Just so it's very easy to make silly mistakes with this one if you don't sort of extend your table. So just to make sure that you don't lose any silly marks, make sure that you draw a midpoint column. So the midpoint between 20 and 30 is 25. 30 and 40 would be 35. 40 and 50, 45, 50 and 60, 55, and 60 and 70, 65. So we've got all our midpoints and we've got our frequency. All we need to do now is plot them against each other. So if I zoom in a little bit here as well, so we can see the graph a bit clearer. So we want to plot 25 against the frequency 8. So we're going to go to 25 and go up to 8. And then we've got 35 and 13. So that's over here. And then we've got 45 and 25. 45 and 25 would be up here. Then we've got 55 and 10. So that would go here. And 65 and 4. So that would go here. Then the last thing to do would just be to draw straight lines which go through, which link 2 points next to each other. So bear in mind, a frequency polygons is not the same as a straight line graph. You're not going to have one straight line that goes through the points. And also make sure that you're not mistaking frequency polygons for scatter graphs either. Scatter graphs are different, where you have many points and then you have to draw a line of best fit. So with frequency polygons, you have a line which goes through each individual point. So please remember that. And then we also have something called a time series graph. Now, as we can see in the example to the bottom right, a time series graph looks very similar to a frequency polygon, but they are different. So a time series graph represents how something changes over time. So we always have time on our x-axis, and then we have our frequency on our y-axis. So to plot a time series graph, you would just plot time against frequency. Now, time can be in hours, months, years, minutes, seconds, anything like that, as long as it is a time or a time period. They are similar to frequency polygons, but remember, frequency polygons use grouped data with categories, whereas time series uses time. So please remember that difference. So an example question is one here. So here the table shows the average number of customers per day entering a shop. So they've got, in our table, we've got the months, and they've sort of split that into similar to the seasons, and not quite, but they split it into quarters. And it's got 2015 and 2016. And they want us to first complete the time series graph. So all we have to do is plot for each time period, the frequency, and draw lines between each of our points. So let's zoom in here as well. Here we go. So they've already done 2015 for us. We now need to do 2016. So if we go to January to March and plot 130. So January to March is here. I'll get the pen quickly as well. January to March is here, and then 130 would be here. So we put an X there. April to June is 304. Now bear in mind, the scales go up in tens. So 304 is going to be a little bit more difficult to plot, and I can zoom in a bit more, try and make it as accurate as I can. But it's going to be just between 300 and 310. So let's go to 300. So it's going to be around here somewhere. And then July to September is 381. So 380 is over here, so it'll be very close to 380. And October to December is 192. So let's go to 190, and it'll be very close to that point there. Now in your exam, if they do, this is a past paper question, by the way, it's okay to not draw it perfectly, obviously, because the scales aren't going up in ones or twos. It's very difficult to find to sort of accurately draw 304 or 381, but as long as you're very close to where it should be, you'll still get the mark. So to finish off this part of the question, all we now need to do is join all of your points with a straight line. And then once you've done that, you would get 4 marks for this question. Oops. Okay, so that is that. So the next part of the question is now asking us to, if I zoom out quickly as well, the next part of the question is asking us to make a couple of comments based on the number of customers entering the shop in 2015 and 2016. So there are a number of comments you could make based on the data on the graph. But one thing that you shouldn't do is, because it's specifically asking you to comment on the number of customers entering the shop, do not talk about the shape of the graph. The shape of the graph doesn't tell us how many, it doesn't tell us how many customers are entering. If you say something like the graph is increasing or decreasing, be specific with what you mean. If you are going to say that it's increasing, say that the number of customers are increasing between these months and these months. So for example, you could say, in general, between 2016 and 2015, there's a large increase between months January to March and April to June. So these parts here, there's usually a big increase in number of customers shopping. Another thing that you could comment on is, you could comment on which seasons. Since we've split it into quarters, you could talk about the seasons. You could say usually in the summer months, so July to September time, those are when you have the most customers shopping. You could also just compare overall 2015 and 2016. So say that there are more people shopping in 2016 than there are in 2015. That would also get your mark. Just make sure when they do ask you to make comments on any sort of graph, you make sure that you make specific comments and not generic comments, otherwise you will lose marks. So the next one is bar charts. So there are sort of two types of bar charts you could be asked in your exam. The first one, a normal bar chart, shows the frequency of events occurring. So like say at the bottom, the graph nicest fruits, that's a normal bar chart that we're all familiar with. Now the heights of the bars is the frequency for each event occurring. So let's say if we look at the nicest fruits one, we know that 35 people prefer apples and 40 people prefer blueberries. Now the other type of bar charts you could come across in your exam is comparative bar charts. So these bar charts are used to compare more than one set of information. So if I zoom in here as well. So here we've got both of these are actually exactly the same data. Well, yes, they are exactly the same data. They're just displayed differently. So they're both showing the number of visitors in a given month, and they've separated with child visitors and adult visitors. Now you could get a stacked comparative bar chart, which is the one shown on the left. So when you have your bars stacked on top of each other, or you could have your bars next to each other on a bar chart, like the one shown on the right. Either one you could be asked, and you have to be able to interpret them and also draw them as well. Now, one thing to remember is that you always need a key in comparative bar charts. Now, the key is this part here, which I'll show you. These are your keys. This tells you what each bar is representing. Now, they either color them differently or they might shade one and not shade the other one. So let's go through how to draw bar charts. So one thing to remember, if you were given a blank grid and they asked you to draw a bar chart, always remember to title your bar chart. Giving a title might, remembering to give a title will give you a mark, but if you forget to do it, you can lose a mark as well by just not titling your graph, so make sure you do it. Label your vertical and horizontal axes properly and make sure that you use a sensible scale. So make sure that it's going up in 2s or 4s or 10s, whichever one is appropriate for the question and the data. Make sure that you draw equally sized rectangles or bars for each category, and make sure that your height is actually representing the correct frequency for that category as well. And make sure that there is an equal size space between each of your bars, including the first bar and your vertical axis. So we're going to go through an example on how to draw bar charts and get the full marks for the question. So here we've got a table which shows information about the birds in a garden. So we've got robins, sparrows, wrens, and larks. So they want us to draw a bar chart from scratch. So what we should first do is give our bar chart a title. So we're representing birds and the number of them. So any title which makes sure that you use the word birds will actually get you a mark for this question. So you could say something like number of birds in a garden. That would be perfect to get you a mark. So number of birds in a garden. You could also say types of birds in a garden, as long as you use the word birds. That's the most important thing. So number of birds in a garden. So the next thing that we need to do is draw and label our axes. So let's draw our axes. So we've got a vertical axis here. Oops. So we've got a vertical axis here. And if I can move it, doesn't seem like I can. And then we also draw our horizontal axis as well. And then we can go ahead and label it and give it a proper scale. So on our horizontal axis, we're going to have our categories. Frequency always goes on the vertical axis, yeah? So let's label it first. So we've got birds over here. So birds will be our category, and frequency, which I'll just write over here. So frequency is our vertical axis. Now you can have each category of birds on your x-axis as well. So let's say robins, then you have sparrows, wrens, and larks. And frequency, now the minimum is 1, the maximum is 5. So the best thing to do is just go up in ones. It'll be very easy to tell. So you've got 0, 1, 2, 3, 4, 5, and I would say just this is enough to draw as well. So that's perfectly fine. Our scales are fine. We've labeled our graph and we've labeled our axes. The last part to do is actually draw the bars on the bar chart. So for robins, we know that it's going to go up to 2, so we can draw. Now remember to use a ruler when you are doing this. It's just quicker for me to draw it like this for a second. So we've got robins, which goes up to 2. Sparrows has a frequency of 5, so we want a bar that goes all the way up to 5. Wrens, a frequency of 3, so it goes all the way up to 3. And larks has a frequency of 1, so it goes up to 1. And this would get you 4 marks. Now before, what I was saying is that your bars have to be equally sized. So here I've just made sure that each bar is 1 square wide. And also it also has to have equal size spaces between each of the bars and the vertical axis. And I've made sure that there is at least 1 square between each bar and including the vertical axis. So this would give you 4 marks for a bar chart question. Now, common mistakes people make with bar charts is not equally spacing their bars, not using appropriate scales, not using a key with comparative bar charts, and not giving a title to your graph. So always remember to do all of these things. Otherwise you will lose marks. So let's do a quick quiz. So which of the following is not a reason why the bar chart on the right is wrong? So there's a number of things wrong with this. I'll let you have a look at the table and the graph, and then pick which one is not a reason why it is wrong. So A, there's no key. That is a reason, because there isn't a key and it is a comparative graph. B, Friday's drinks bar is wrong. So if we look at Friday's drinks bar, it says sales of food is 22. So it goes up to 21. It goes up to 22 here. That's fine. But sales for drinks is 48. Now, if we look at the difference between 22 and 48, the difference between 22 and 48 is 26, not 48. So remember, each of your bars has to have the height of the frequency, not necessarily hit the frequency on the vertical axis. Yeah, so the heights of your bars, how long is your bar, that's how that's what should be representing your frequency, not where it hits the axis, especially when you have stacked bars like this on a comparative bar chart. So B wouldn't be our answer. C, Saturday's bars are the wrong way around. So if we look at this, so with the diagonal lined bars, Thursday, this shows our sales of food. Friday, this also shows our sales of food. But Saturday, this shows our sales of drinks, not our sales of food. So if we did have a key, and if we did draw our key, we'd realize that Saturday's bars, they've mixed them around. this one is sales of food and this one is sales of drinks. So if we just shaded them the other way around and swapped them, then it would be correct. So our answer for this one, a reason which is not a reason why this graph is wrong, is the axes are not labelled properly. The axes are labelled properly. We've got sales in pounds. We've even got our units, and days is labelled correctly as well. So the next graph that we're going to go through is a pictogram. So a pictogram represents the frequency of events using pictures. So again, just like comparative graphs, a key is absolutely necessary. Otherwise, we don't know what the picture represents. A picture could represent 2 cupcakes in this case, or 5 cupcakes, but they've told us that it's 6. So we know how many cupcakes for each day was sold. So let's do a quick quiz with this. So 4 friends play tennis a lot together throughout the year. The pictogram below shows how many games each person won. If Alex won 44 games this year, which of the following is the correct key for the pictogram? So would it be 16 games, 20 games, 4 games, or 8 games? So if we look at Alex, we can see that we've got a representation of how many games he won using tennis balls. Now, if we split each ball into quarters, then we could count how many quarters of a ball we have and equal that to 44, and then work out how much 1/4 of a ball equals in terms of games. So if we did that, we split each one into quarters. So we know we have 4 quarters in the first ball, 4 quarters in the second ball, and 3 quarters in the third one. So when we add these together, we get 11. So there's 11 quarters. Now, if the number of games he won is 44 games, then that means 11 quarters equals 44, which means that one quarter of the tennis ball equals 4 games. Now, what a lot of students would do as a mistake is pick this one here. They would pick this answer. But remember, this is a whole tennis ball, not just 1/4 of a tennis ball. So now we need to multiply it by 4 to work out what a whole tennis ball is equivalent to. And 4 times 4 is 16. So 16 would be our answer for this particular question. So be careful with the sizing of your pictures in your pictogram as well. So an example question, so we've got the pictogram here, which shows information about the number of books sold by an author in January, February, and March. Now, we've got a square, which is split into quarters again, and the whole square represents 8 books. Now write down the number of books sold in March. So what we can do is we know that if 4 quarters equals 8 books, that means that 1/4 of my square equals 2 books. So first of all, I've got a whole 8 books here, another 8 here, another 8 here, and then another 2 here. So it'd just be 8 plus 8 plus 8 plus 2, which would give me 34. Sorry, 24, not 34. 26, sorry. My mind is going today. And then 14 books were sold in April. So they now want us to show this on a pictogram. So one thing that a lot of students do lose marks in is not drawing the squares roughly the same size as the squares given to them in the question. You don't want to draw a big square like this and then split it into quarters. because realistically 1/4 of the square that I've just drawn here looks like a whole square in the actual question. So make sure that the sizing of your shape is roughly the same as what's given to you already. So 14, how do we split that into 8? Now we know that 1 whole square is 8. So we've already got 8 here. And then we have 6 left over that we need to draw. Now another whole square would just give us another 8. So that's too many. So we know that we could have 2, which would get us to 10. Another 2, which would get us to 12, and another 2, which would get us to 14. And that would be the correct way to draw your pictogram. And the last part of this question is now saying, what was the total number of books sold in these 4 months? So all we need to do now is add up the total. So we already know that March is 26. We also know that April is 14. And then we just need to figure out what January and February are. So January is 8 plus 8 plus 2, which gives us 18. I'm sorry, 8 plus 8 plus 4. I'm really messing all of this up today, sorry. 8 plus 8 plus 4, so we get 20. And this just shows how easy it is to make mistakes when you're working with pictograms. So please don't make the same mistakes that I am making. Be more careful. And then 8 plus 8 plus 8, which is 24. So all we need to do now is add up 26 plus 14 plus 20 plus 24, and we will get 84. So 84 would be our answer for this question. So please be careful with making mistakes, and also it is okay to make mistakes as long as you pick up on them and you learn from them as well. So we've gone through the common mistakes already. So people usually don't draw the pictures the same size as the pictures given in the question. Make sure you read the key properly. It is very important. And if you are drawing a pictogram, make sure that you add a key also. So the next one that we're going on to now is pie charts. Now pie charts, quite a common question that they asked in the exam. So I would bear in mind, really try and work on pie charts if it is something that you struggle with, because it comes up a lot in past paper exams as well. So to draw a pie chart, first of all, a pie chart represents proportions of an amount by a circle, like shown in the bottom 2 examples. And the proportion of the frequency is represented by the equivalent proportion to 360 degrees. So remember, the angles around a point all add up to 360 degrees. So to represent a proportion, we would just represent this with the proportion out of 360 degrees. So here we have a pie chart showing favorite type of movies and then favorite flavored crisps. So let's move on to how to draw a pie chart. So to draw a pie chart, what we should do is calculate the proportion of the frequency by dividing the frequency of a particular group by the total frequency. And then we will multiply this by 360 degrees to find the angle of the sector of our circle, which we're going to represent this category with. And then we will use a protractor to draw the sector of the circle with the correct angle. So always make sure that you're using a protractor when you are working with pie charts. It's very important to make sure that you get your angles correct. So if we look at this particular question, I'll zoom out a little bit as well. A group of football fans were asked what their halftime snacks was. So the table shows us a burger, pie, or a hot dog. So what we need to remember to do is always work out what the total number of people are first. So we want to do 11 plus 17 plus 8. And when we do that, we get 36. So you can just add this to the bottom of your grid. So you've got a total, which is 36. So now for each one, what you need to do is you need to work out the proportion and multiply it by 360. So you do 11 out of 36 multiplied by 360, and that will give you the angle of your sector, which you're going to draw on your circle. So 11 out of 36 multiplied by 360 gives you 110 degrees. And then we do the same thing for the rest of them. 17 divided by 36 multiplied by 360, and 8 divided by 36 multiplied by 360. So the first one gives us 170 degrees, and the second one gives us 80 degrees. And if we were to add up all the degrees together, we would realize that we get 360. So the last thing to do would be to use a protractor and make sure that you put your protractor at 0 on the first line. So your protractor should end up being put like this, and then you should see where your angles are pointing towards, and then you draw it that way. It's a bit hard for me to do that on a computer, so I'm just going to show you what it roughly should look like. So 80 degrees, I'll start with that one first. 80 degrees is just below 90 degrees, so it should be something like this. 110 degrees is a little bit larger than 90 degrees, so it might look like this. And then the last one would be 170 degrees, which is just under half of the circle. So the last thing to do is to label what each of your sectors should be for your pie chart. So the 80 degrees, the smallest one was hot dogs. The second one was burgers. And the last one, the largest one, was pie. So you should get, when you do this question, or do a question similar to this, you should get a pie chart which looks just like this. Always make sure you're using a ruler to draw straight lines between the center of your circle and the circumference of it. So if we, just because of time, if we quickly go on to scatter graphs as well, just so we can at least go through it. So scatter diagrams. So a scatter diagram shows a connection between two events. So the correlation of the graph tells us how two outcomes are related. So for instance, if we look at the bottom, we've got a scatter diagram for maths marks for paper 1 and maths marks for paper 2. You just want to see what the relationship between the two are. Now, if you have graphs which are going up, like say this one here, if you can draw a line with a positive gradient through the points, then that would be a positive correlation. So that means as one maths mark goes up, the other one goes up as well. If you would draw a straight line with a negative gradient, then that'd be a negative correlation. So as one goes up, the other one goes down. And if there isn't any correlation, so you can't draw a line, then we'd say that there is no correlation. Now, with scatter diagrams, you also should know what an outlier is. So an outlier is just a point which doesn't necessarily fit the pattern on our graph. So for instance, this point down here, it doesn't suit the pattern to our graph. The pattern is going up, whereas this one is kind of way towards the bottom right, which doesn't really look right. So that would be an outlier. So looking through our scattered diagrams, these would be examples of correlations. So positive lines, so if we start from the bottom and we go up towards the right, that would be a positive correlation. Negative correlations would be starting from the top and working its way down. And no correlation would be when you can't draw a line which would show what the correlation would be. So usually your points are all bunched up or really spread out as well. It's quite obvious to see when there's not a correlation. One other thing is that you should be able to tell whether it's strong or weak. So it's strong if all your points are quite close to each other, like say when we look at the strong positive and strong negative, and it's quite weak if your points are spread out quite a lot and they're not very close to your line of best fit. So just to quickly finish off with scatter diagrams before we open up for questions, just like to show you how to draw a line of best fit. So your line of best fit sort of tells us what sort of correlation it will be, and it gives us something that we can use to estimate. So a line of best fit is a sensible straight line that goes as centrally as possible through the point on your scatter diagram. The line should follow the same steepness as the points on the graph, and to try and center your graph, the best thing to do is have the same number of points above your line as there are below your line. So that's pretty much diagrams, charts and tables for data. So does anyone have any particular questions about it? So someone's asked, is a time series graph like a line graph? Not quite. A time series graph uses straight lines, which goes through each point. So if I go back to time series for a second, I think it was over here. Yeah, so, oops, not that one, this one here. So time series graph, a line graph is when you draw a straight line that goes through all your points. That's a straight line graph. A time series graph is just straight lines which connect each of your points. So for instance, if I draw an example of a line graph down here, if I move this, there we go. So a line graph would be something like this. Yeah, where it's just one straight line which goes through each and every single point which you plotted on your graph, whereas a time series graph does not do that. It connects different sorts of lines, but between each of your points. So that's the difference between a time series graph and a line graph. Are there any other questions? No? Well, if not, then I can sort of continue with some of these quizzes that we might have missed out. So let's look at this particular quiz for scatter graphs. So we want to match the correlations to the scatter diagram. So which correlation goes with which graph? So A, we could draw a line that goes through the points. Oops. From the bottom going upwards like this. I'll quickly show you. So we could draw a line that goes something like this. And that line would be, it would have a positive gradient, wouldn't it? So that would be a positive correlation. These two would match up together. B, we can't draw a very obvious line that would go through any of these points that would make it more obvious to see what's going on. It's just random points plotted around each other. So this one would be a negative correlation. So, sorry, a no correlation, not negative correlation. And the other one, you'd have a line which goes down something like this. Now, even though it's a weak correlation because the points are quite spaced out from each other, it's still negative. So you would match it with a negative correlation. So someone's asked, what makes a correlation positive or negative? Back to the drawings that we had here. So a positive correlation would show a straight line which goes, starts from the bottom and goes up. So it's as if you were drawing a straight line graph with a positive gradient. So it's something that goes up. So what it would show is that as your x-axis or values on your x-axis go up, then so do the ones on your y. They also go up. Now a negative correlation is the opposite way round. So it's when you have a straight line and it goes downwards. Yeah, so if you were to draw a straight line graph, this would have a negative gradient. That's why we call it a negative correlation. So as your x values increase, your y values aren't increasing this time, they're going downwards, they're decreasing. So hopefully that clears up the difference between a positive and a negative correlation. Are there any more questions? If not, we can go through some exam, some past paper exam questions. Okay, so let's quickly look at this particular quiz then. So Lee sells ice creams, and the table shows the midday temperature and his sales for 5 days. So he's drawn this scatter graph and his line of best fit. Now, which of the following are reasons why this scatter graph is incorrect? Now, there are 2 reasons, so you could pick any 2 of the 4, which would be the correct reason why his graph is wrong. So I'll let you have a look. So if we look at the first one, so Lee has not plotted 17 and 80 correctly. So if we go to that point there, so that would be day 3, 17 and 80. And let me get my pen as well. So if we go to 17, 17 is over here, and this point is definitely not at 80, it's at 60. So this is a reason why it's incorrect. The line doesn't go through 0, 0. One thing to point out is that a lot of people think that when you draw a line of best fit, it has to go through 0, 0. It doesn't. That's something that we have to forget about. Your line doesn't have to go through 0, 0. Your line also doesn't have to go through the axis at all when you're drawing a line of best fit. That's not a correct reason why a graph would be wrong, and that's also not something which you have to do when you are drawing a scatter diagram. So that's not a reason. The line is not steep enough. Now, if we look at the points that we've plotted and we look at the line of best fit, the line of best fit doesn't actually go with the steepness of the points, does it? We should really have a line that goes something like this. So yes, that would be a reason. Drawing your line of best fit, it does have to go, it does have to have the same sort of steepness as your points so that you are able to use it properly. Which means that the line should go through all of the points is not a reason why the graph is incorrect. With scatter diagrams, again, it's not a straight line graph. Your points will not go in an equal line. So there's no way how you can draw a straight line that goes through each and every point. But you can draw a straight line that is very close to all of your points. So let's look at this past paper question then. This one is on bar charts. So here is a bar chart showing the average maximum monthly temperature in Greenwich. So here are the average monthly temperatures in October, November and December. So complete the bar chart to show this information. So remember, when we were talking about bar charts, we have to make sure that they are equally spaced out and that the height of the bars represent the frequency or the data properly. So here for October, we want to make sure that it reaches 16. So we will use a ruler when you are doing this in an exam, and you will do the same with bars which go up to 16 and have the same equal spacing as all the other bars in the graph already have. Same thing we're going to do with November. So it's going to go up to 11 degrees. So it's going to go up to around here and then back down. And then December will go up to 8 and back down again as well. Now in your exam, some people shade it, some people don't shade it. It's not, it doesn't actually give you a mark as long as you've got equal spacing, equal size widths of your bars, and they also go up to the right data point as well. You'll get the mark. The shading doesn't really make a difference. So in which 2 months were the highest average temperatures recorded? So what you do is you go to the highest temperatures, which would be the bars with the highest, the bars which are the tallest, and that would be at July and August. So you can write the months fully, or you can just write them in the same way how they're written on the graph. That's absolutely fine as well. Then the last thing is work out the range of the average monthly temperatures. So if we remember back to our statistics, our means and averages, then our range would be our highest take away our lowest. So the highest temperature is 23 and our lowest temperature is 8. So we just do 23 take away 8 and we would get 15. So 15 would be our answer for this one. So we probably have time for one more question, which I will do on pictograms. So this one is a past paper question from Edexcel, November 2017, from paper 3. So here we have an incomplete pictogram which shows information about the number of cycles sold in the shop on Tuesday, Wednesday, and on Thursday. Now, it says that a total of 20 cyclists were sold on Tuesday, Wednesday, and Thursday altogether. 8 cycles were sold on Friday, and 15 cycles were sold on Saturday. So use this information to complete the pictogram. So first of all, one thing which a lot of students didn't notice was that you had to fill out this key as well. The key is part of the pictogram, so don't forget that. Now they've told us that the total number of cycles sold on all 3 days, Tuesday, Wednesday, and Thursday, is 20. So what we can do is we can split them into halves, then add up how many halves we have, and then work out how much half of a circle is, and then work out the key that way. So we've got 2 halves from Tuesday, we've got 1, 2, 3, 4, 5 halves from Wednesday, and we've got 3 halves from Thursday. When we add this up together, we get 10. Now that means 10 halves equal 20 cycles, so that means 2 cycles equals 1 half. Yeah. One half of one of the wheels. So that means that a whole wheel, so if we were to draw this, would be equal to 4 cycles. And you have to specify what exactly we're talking about. So if you wrote a wheel equals 4, that doesn't tell us 4 of what. You have to make sure that you be very specific. So it equals 4 cycles. And then the last thing to do is to now complete the rest of the pictogram. So for Friday, they sold 8. So we would draw 2 circles or 2 wheels. Make sure that they're roughly the same size as the other ones. They don't have to be perfect, as long as it's obvious what you're trying to draw. And then on Saturday, you'd want 15. So you know that when you draw 1, that's 4. Then we have another one that would make 8. Another one would make 12. But then we don't want another 4. We only want another 3. So you would draw 3/4 of the cycle like this. And this would be enough to get your mark. And so someone's asked, how do you get 2 cycles equals 1 half? So what I did is they've told us that the total of 20 cycles was for Tuesday, Wednesday, and Thursday. So I split each of the wheels into a half, and I counted how many halves we had. So we had 2 halves on Tuesday, we had 5 halves on Wednesday, and we had 3 halves on Thursday. So we had 10 halves of a circle. Now that means that 10 halves of a circle equal 2 cycles. So 1/2 equals 2 cycles. Hopefully that makes a little bit more sense. And then from there, I just made sure that you had a whole circle. So when you had a half and a half together, so you have 2 cycles plus 2 cycles, so you get 4 cycles for the circle. And hopefully that clears it up for you. And that's the end of today's session.
Brilliant, thanks so much, Evelyn. Just wanted to check that this question got answered earlier, so let me know if it did. There was a question asking, how do you estimate the line of best fit?
How do you estimate the line of best fit? So if we go back quickly to that part. So line of best fit. So what you should do for line of best fit is, first of all, look at each of the points which are plotted on your graph, and then sort of try to see how steep are these how steep are these points. So if we were to look at, let's say, this one, for instance, for a second, these points all have the same sort of steepness. So we want to fit a line which goes sort of central to each of those points. So when you do draw a point and when you do estimate the line of best fit, try to draw a line, or try to put your ruler and move your ruler slightly until it looks as if you could draw a line center of those points, and then make sure you have the same number of crosses or points above your line as there are below your line, so you try and get it as center as possible. Hopefully that answers that question.
Brilliant, thank you. I think that was all the questions we had, so thank you very much for today's session. Thanks for attending, everyone. I hope you found that a really useful lesson today. If you want to join us for any other sessions we have today, just a reminder that we've got a couple more this afternoon. We've got physics at 2, and then we've got another maths session on transformation of curves part 2, led by our other maths tutor, Molly, at 3:15. But otherwise, see you in your next Maths Foundation session, and have a lovely rest of your day. See you soon, bye.
Bye.